Okay, so the next code in the lead code is we're solving is routing oranges. Okay, this is a graph based problem. Okay, let's see how what is this problem about. Okay, so let's say that there are mangoes, okay, or oranges, like let's swap whatever it is. Okay, so let's say that we have a mangoes, okay, and in a basket, or we can call it as a grid. Okay, and there are some rotten mangoes also. So in practically what will happen is, like, if you have a mixture of good and rotten mangoes, right, the possibly that rotten mango will also rot the good mangoes, correct? So that is the theory here. So what's happening here is, let's say that we have a grid here and we have a basket. So this is, we have one rotten mango. Okay, so possibly what it will do is, it will spoil all the neighbor mangoes also. Okay, neighbor whichever it is, like nearby, right, that will spoil it. And the what is happening here is, like, for every minute it is spoiling the neighbor ones. So let's say that once this gets spoiled, right, it will take 1 minute to spoil the neighbor ones. Okay, this is the problem about. So now what we are asked to find is, we'll have to identify, like, how many minutes it will take to spoil all of this. Okay, that is one thing. And also, if we are not able to spoil it, okay, let's say that there is one mango which is not touching any of the mangoes. Okay, in that case it will not route, right? So in that case we'll have to return a -1. Okay, so this is the problem about how we are going to approach is, we are going to, this is a, like, kind of this is not like, if you just look at the data structure, right, this is a graph, correct? Like, I mean, it has multiple possibilities. Let's say that we have right here, right, we here it has two possibilities. Like, if it is a tree, that's fine, like, yeah, it is a true possibilities. But if you consider this one, it has ideally four possibilities. Let's say that here we don't have anything at the moment. Let's say that this is three possibilities. Obviously, like, when it is more than two, right, like, I mean, and this is a graph thing. Okay, so now, right, okay, now how to, like, now we know it's a graph. Okay, now which one to apply, if it is a BFS or DFS, right? Like, let's go with the BFS approach here. So what we are going to do here is, basically we'll have to okay, before actually going to the BFS, right, we need to be having the understanding of how that BFS search works, correct? So if we already solved problems like BFS on the trees, right, then we are good here, because that's almost the same. It is almost the same, even by the coding wise and even the algorithmic wise, correct? So let's see, I'll quickly see how the BFS works in the graphs. Okay, in the tree, what we'll do is, we'll have a one queue, and we'll have one queue, and we'll whenever we visit that node, right, like, I mean, the tree, so we'll add that to the queue. And whenever we pop that element, we'll make sure to add its child node to the queue, so that we can use that those child nodes to iterate for the next one. Okay, so similarly we'll do the exactly the same thing, but it's just that we will be having too many connections here, right? Okay, more than two. So to do the search, like to search if any element exists, I can just to do BFS here. And so let's say that I can start from anywhere. I can start from 2, I can start from 3, anywhere. But I will, let's say here in this example they have started at 0. Okay, so we will start at 0. Okay, so what will start an iteration. So once we'll add this to the queue first. Okay, we'll add this to the queue. And during iteration, we'll do this iteration until the queue becomes empty. Okay, so let's say that I will pop this out. In the time I popped it out, I will also have to update the its connected nodes. Okay, its connected node is 1 and 2. Okay, and similarly when I pop 1, I will have to update 3, but not 2. We'll also have to, for that we'll have to make sure of maintaining one more list, which is visited node. So when we going to come here, we should not be adding 2, because 2 is already added in the queue, right? So that's why we'll be maintaining this. Yeah, that's it actually. Like, I mean, whenever we pop the element, and we will be have to update the reference other nodes, and so that we can track the further graph, and we can identify if the element is present in this graph or not. That's about breadth first search. So we are going to use the same. Okay, but what is the twist here? So the queue is this algorithm. What is helpful for? It is helpful for, if to find out if the element is exist in the graph or not, correct? We'll search through it, and if it exists, will be we are good. As the name suggests, it is helpful for searching. But here, what is the requirement is, we'll have to send back how many times it took, like, how many minutes it took to route on the all the oranges or mangoes that are present in the basket, correct? So what we'll do is, currently, so far what we have done is, BFS, we'll be adding the nodes. When we say adding the nodes, we'll be adding the, we can say we can add the coordinates, correct? X comma y we can add, let's say that here, right, this is the one node, we can add X comma y. Okay, but here we'll also have to track a steps. So to coming to, we'll also whenever we are adding a node to the queue, right, we'll also track a steps also. That's it. Okay, so whenever we add this node, we'll say that this is that we'll add a steps as 0. Okay, X comma y comma 0. And because why I'm saying X comma y, because we need to move top, bottom, right, and left, right? So that's why what we'll do is, we'll track X, y, and also the steps count. What is the steps now as far as now? Okay, so now let's see how it goes. Okay, so currently we are here and the steps is 0. There is a minute is 0. You can either say minute or steps, whatever it is. Okay, so what will happen in the next is we have added this to the queue and with the value 0. So when I pop this element, what I will have to do, I will also need to add the I will have to add the neighboring nodes. Correct, that's what happened here. Correct, will this is a 0, we'll have to add the neighboring nodes. And how to identify the how to find the neighboring nodes? In general, right, there will be a graph. What is happening here is there will be a graph, and graph will is nothing but a dictionary, so that will have that information. 0 is mapped to 1 and 2, 1 is mapped to 0 to 3, 2 will map to 0 and 4. Okay, using that we can just map it, like we can find out what are the adjacent nodes, we can add it to the queue. But here it's not like that, we don't know that, right? We don't know what is mapped, we don't have dictionary or anything. But here what is the condition given? It is we can this will rot only left, right, top, bottom. That is the given condition. So we that's how we'll know that what are the neighboring nodes of the current orange or mango. Okay, what are the neighbors? So what we'll do is we'll have to find out what are the neighbors. So it's like an axis, right? Nothing but it's like here if you go, we are currently here, we'll have to find out the neighboring elements at this location. Correct, it will be like +1 -1, those kind of things. This will be like 1 comma 0, because like I mean +1 comma 0, right? We moved only direction in the x, and it will be like 0 comma y, 0 comma 1, because we moved only in the y direction. Similarly, it will be in the opposite direction. Okay, so if I know this coordinate, I can easily get the neighbor coordinates. Correct, by adding these values, I can get the new coordinates, neighbor coordinates. Okay, so now what will I will do? And also here here one thing, right? If we just split it like the +1, right? Let's say that we do this. Okay, we need to make sure that whatever the value that comes right after adding, we need to make sure that it doesn't overflow our grid, because there is no element, right? Or else we'll get an error. So we'll have to handle those cases also. Okay, so now we are here. Okay, so we have added this node. Once we popped it out, what we'll have to do, we'll have to add the neighboring nodes. So how will we find the neighboring nodes? By adding these coordinates to the existing one, we'll get the neighbor nodes. We'll get this and this. We'll be ignoring these two. Okay, and now what we'll have to do next thing is we'll have to check if it is a good mango, or if it is like blank or whatever it is, right? We'll have to check if it is a good. Okay, so once we identified that good, we'll be adding this to the queue again. Okay, and whenever we adding this to the queue, we need to make sure to add the x, y, and also the steps, whatever the steps we previously add, +1, because that's what is the answer, right? Let's say that we don't have anything else here, so we had 0, and in 1 minute it will be these two will get rotten. Correct, we'll say that we are at here at 1 minute. Minute 1 is the answer. Minute 1 is like, let's if there are no element there, right? So I'm talking about that. Okay, so whenever we add it, so we need to track an element to track the steps, so that's why we are using the third argument. Okay, so that is there. So now what we'll do is once we are done with this, we'll added this with steps as steps +1, and we also do the same, adding this coordinate with the steps +1. Okay, so now, okay, what will happen is now in the queue there are two elements. Okay, this is popped out. Okay, similarly what we'll do in the next element is also we'll pop this element and we'll do the same thing, right? So what we'll do, we'll take this, sorry, let's we can to take this also. This will make our task easier, so I will to explaining things. So I will just take this node. Okay, we'll take this node. So what is the thing that we need to do now? We need to do the calculation, like I mean which is the neighboring node. So this is one neighboring node, neighbor node, neighbor node, neighbor node. This will have to ignore, because it's not a valid allocation. This will also ignore, this is not a mango at all, like this is not a good mango. This we already visited, right? This also will have to ignore. And finally we found some good mango here. Okay, so we'll be taking into consideration this. Okay, whenever we are doing this calculation, we just popped it element, right? This we popped it, and we are looking for some neighbor elements to add it to a new queue. Okay, we just popped it, so we found one neighbor. Okay, so we will be adding this. So what do we need to do? We'll have to find out the coordinates of this, whatever it is, and we'll be adding the steps, whatever the steps was 1 1, right? Will be, it will be steps will be 2. Whenever we inserting the node with the steps will going to be 2. Okay, and there was one more node in the queue, right? So we'll do the same thing. We'll do the find the nodes, top, left, right, bottom. Left is already visited, and bottom is already visited, and there is one good mango. So with this will be also 2, whatever the element that is previously 1, right? It will be become +1, so it will be 2. So yeah, that's how we are going to do it again. So this will be going to this way, and this will be going to route this one. Okay, so now this is the algorithm. Let's see the code. Okay, like how this worked so far. So okay, like to for coming to the problem, right? What we'll do is we'll find out first what is the grid size, okay, length, row and column, and also so far we found we are solving the problem for only one rotten mango. There is nowhere it is mentioned that it will be only one. It can also be two also, I believe. So it is coded in such way, okay. And rotten location are this. Okay, so what we'll do is we'll iterate to the grid and we'll identify where there is a rotan algo, wherever it is a true or two. Okay, if it is a 2, mark the get that rotan location, and first we'll be adding all those rotan location to the queue. For in this case there is only one rotan, so we'll be adding that. Steps will be 0, right? Minutes will be 0 at that time. Let's say that there is one more rotan here. Okay, one is written here and one is written here. So and in the middle everything is good, so it will be like step 0, step 0. It will be less minutes, it will take less minutes in that case, correct? So it will spoil this, in the same time it will spoil this, correct? And in the next minute it will this will be spoiling it and this will be spoiling it. I think we'll be getting the answer around 2 or 3, I guess. So let me analyze. 1 second. 0 0, okay. 1 1 1, okay, and 2. I think the answer will be 2, like just if there is one more rotan orange in the beginning itself, right? The minutes will be 2. Okay, so that's why. So whenever one thing we need to keep in mind is we know we need to keep a stack of steps, so that's why we'll be adding the steps also. Okay, so now queue is updated. Okay, now we'll have to check the visitor nodes, like let's have it, right? Because we already consider this rotan oranges, so we'll put it in the visitor nodes. Okay, and this is the possible directions that will be helpful for our calculation. Like we'll be adding this to the current node so that to get the neighbor location. Okay, so first foremost thing, we have added some route oranges, right? So we'll be popping it out and we'll be checking the steps, we'll be getting the coordinates. Okay, so first thing what will happen is we'll get the coordinates for this one. Let's take an example of this one. Okay, so we'll get this and we'll find out first. Next thing what we'll do is we'll start finding out the neighbor coordinates. Okay, so we need to make sure that as we just discussed so far, it should not be already visited, correct? Let's say that if we are evaluating, right, there will be duplicates, so we need to make sure that we are not going to the duplicate tanks. And next thing, we'll need to make sure that it doesn't overflow, because it should not consider top and left in this, right? It should not overflow, and it is a good mango. If it is not a good mango, just ignore it. These are the three conditions that will be taken into consideration. Once we visit it, we'll have to add it into a queue. Okay, add it to the queue and make sure that, so we found a good mango, so we'll add it to the queue, and along with that location, what is the step counter. Okay, we'll be adding that. And visitor nodes, visitor nodes, we are not adding a steps, because we just want to check if that node exists or not. We don't care what was the steps. We just want to make sure that it was visited or not, right? That is it. And also we need to make sure that to mark the previous one as a router. Okay, so to identify at the end, right? So I believe this much is clear. So the next thing is we'll have to, at the end, what we'll do is we'll check, we have marked as a router, right? At the end we'll see if there are any of the element that is still fresh. Okay, if it is still fresh, we'll have to return -1, because all the elements are not rotten, all the mangoes are not rotten. If it is not, we'll just return the steps. So here we have initialized it to 0, so we can access it here. And we had maintained it, right? We steps, right? Steps will be keep on incremented it. So at the end, we'll be popping it out. We are not, if you see it properly, it's not that like steps is equal to steps plus 1. We are just referring to the previous one. We are not like, I mean, this is a global variable. Okay, we are not modifying the global variable. We are instead we are relying on the previous steps. We just popped it. Okay, we just popped it. We are going to use that steps for the next calculation. Okay, and when we pop that element, well, let's say that this is the last element I am popping. Okay, so at that time I will get the last step, so that will indicate the last minute. Okay, so yeah, that is it. So this is the problem about. And to check the submission rate, right? Let's see, yeah, this is the submission score, right? Okay, that's it. Thanks.